Hi all, welcome to my session. Today I am going to discuss about the Kubernetes. I mean that uh, what is Kubernetes and like that I am planning to start the Kubernetes session. So for this Kubernetes session, what are the topics I am going to discuss? In that yes, this session I have splitted this Kubernetes session into multiple sessions because we are unable to discuss in one session, so that's why I have bifurcated into multiple sessions. So in the first session uh, I'm going to discuss what is Kubernetes and what it does and what type of mechanism it will provide and how we can utilize that mechanisms and what type of mechanism and what are the mechanisms we will get after configuring the Kubernetes. I will explain you each and everything, and Kubernetes architecture, what type of architecture it is, and like master node architecture and client server architecture. Sorry guys. I will explain you one by one, and different type of master node setup architecture by using the Kubernetes. So for that I have taken one snapshot example. Google, we all know that Google using the Kubernetes. So I will take the one snapshot of Google pics uh, with the Kubernetes architecture. Then I will explain you, and Kubernetes building block. So this is the main thing. And when we are going for any interview, so they will ask the what are the building blocks, what are the key factors, what are the key components in the Kubernetes. I mean that uh, Kubernetes consists of lot of components. So yeah, what type of components it is containing. So mostly in interviews they will ask this question. And the building blocks, uh, a light introduction I will give you in this session. That is the first session. If it is, it will complete in a few. I mean, as per time, I will extend the session 2. That is building block introduction, building block of Kubernetes in-depth explanation. That is master and node components. Master node containing a lot of components like API server, etcd, and controllers and schedulers. And coming to the nodes, a node side, like node containing a lot of components like kubectl and kubeproxy node, as well as the pod and containers, etc. And I will explain you the Kubernetes cluster, uh, like Kubernetes cluster configuration. As per official document, I got some information like when we are configuring the Kubernetes cluster, we can able to configuring the nodes up to 2000 only. It should not exceed, and that nodes, and then in that nodes we can able to configure up to 60,000 pods, and containers, that is 1,20,000 containers, up to 1,20,000 containers we can able to configure. And there is one restriction for the node wise, we need to configure 100 pods only. That is the second session I will explain you. And coming to a lot of sessions I have figured out here, like in the session 3, like Kubernetes network, in a inside the Kubernetes cluster, what type of network it is using, and based on that network, that entire nodes will communicating, like that between the nodes, whatever for and networking we can able to use, and between the pods what type of networking we can able to use, and between the containers which are in the Kubernetes cluster what type of networking we can use. I will explain you in further sessions, as well as the exposing the as a service, that is ingress or egress with the internal load balancer and external load balancer. Once we do the deployment of pods and everything in the node, I mean the dockers inside the pod which are into the node, it is into the cluster, Kubernetes cluster. We want to expose that entire container information as a service, either internal service or external service with using the ingress or egress with the help of internal load balancer or external load balancer. I will explain. And coming to the next session, the fourth session, configuration files for the PV and PVC, as well as the storage based sharing components. When I say the PV is that a persistence volume and PVC is that persistence volume client, I will explain you in further session, session 4, and as well as the dynamic horizontal configuration. That is that we have the a lot. We will configure the Kubernetes once we have configured the Kubernetes. So we need to enhancing the resources like the CPU, memory, like lot of things. We can by using the configuration files we can enhancing, or otherwise manually wise we can able to configure. Later we will discuss in the session 4 and session 5. I will explain your deployment by using the kubectl. It's command line. Kubectl is a command line to interact with the master node setup. And in the session 6, configuring the Kubernetes in the cloud. Sorry guys. Like in a I will take this some Kubernetes test domain or test console. Then I will configure the Kubernetes. So after that I will work on that, like how to configure and manage the Kubernetes cluster, and how to configure and manage the Kubernetes pods as well as the nodes, and adding the new node to the existing cluster using the some Kubernetes existing setup. In that session I will explain you. After that session 8, deploy any container to the Kubernetes, and how to create the deployment and services in that particular deployed uh, Docker container. So this is the overall Kubernetes session I'm planning to explain, but it will take a lot of time to explain each and everything. I told you, right, when we are talking about Kubernetes, it's not a small thing, it's a huge. So for that I have bifurcated into multiple chunks. So in the first chunk, in the first session, I'm explaining these all the things. So for that I have prepared a nice PPT, like sorry guys. So Kubernetes, I told you, right, what is Kubernetes. In this session I will explain you what is Kubernetes, what does Kubernetes do, and architecture of the Kubernetes. I will explain you their components, master components, node components, additional services, networking, and some components like core components, workloads, networking, storage, configuration, authentication, and authorization and identification, and behind the scenes deployment from the beginning of the end, from beginning to ending. I will explain you. Also, uh, yeah, I don't want to waste this time, so let's get into the session. So myself, Hari Krishna Palakila, I'm a senior DevOps engineer in Mumbai in the Reliance Capital. So I told you, right, initial session, that is what is Kubernetes. A lot of people are heard about that, and everyone try to learn, and everyone want to work on the Kubernetes. So for that I have filterized only few things related to the Kubernetes, because a lot of people are asking the first question, what is Kubernetes. So a lot of people are thinking, and they are expose their intentions in different ways. So for that for like that I have summarized, and I have filterized the major facts, not major facts, that is a major some information I have gathered. So those are like first thing is that Kubernetes. So the short form is that KAS. So a lot of people aware of this. We can call it is Kubernetes, or if we can call like K8s. So actually Kubernetes is the open source system for managing the container application across the multiple hosts or multiple nodes in a cluster. So it means that Kubernetes, it is the free version, and it is commercial version also is there, as well as the additional version also is there. So it is it is from scratch. It is an open source system. So for what purpose it is introduced? That is that managing the applications which are hosted in the container across the nodes which are into the cluster. So means that Kubernetes is gives the cluster environment. It is a combination of multiple nodes. In that nodes we will deploy our pods, the pods containing the containers. Sorry guys. So in that containers we will do the deployments of our applications. That applications we need to manage. That is that container based application we need to manage. For managing that container based application we require a tool. So in a market we have a lot of tools, that is OpenShift, as well as the Docker Swarm and Kubernetes. So in that I have chosen Kubernetes. So means Kubernetes is a open source system. It is managing the container based applications in a cluster manner. So after configuring the Kubernetes setup, we will get the lot of mechanisms. So for our applications like that, deploying the application, managing the application, updating the application, scaling the application, scheduling the application. So Kubernetes has a feature, and it's produced the and provide the mechanism itself it's providing a mechanism to us, like managing the application, deploying the application, scaling the application, schedule the application. Once we do the deployment, everything, that is the beauty of the Kubernetes. And it has the loosely coupled architecture. When I say the loosely coupled architecture, the resources inside the Kubernetes, they are communicating with each other, they are sharing the resources each other. So actually we have two type of architectures. One is that a tightly coupled architecture and a loosely coupled architecture. When I say the tightly coupled architecture, means that when we have the multiple resources, so that those resources are depending on other resources. So uh, dependent resources waiting for the resources which are already utilized by the another resources. So one resource is depending on the other resources. When once the dependency resources release their entire resources, then only other resources will able to use, and they will able to do the perform other until the existing resource will be into the stopped state or waiting state. I mean that, for example, I am taking one Kubernetes setup. We have the one pod containing two containers. There is container A and container B. When I say it's a tightly coupled architecture, sorry guys, when the setup is tightly coupled architecture, like a single pod containing it contains two containers, container A and container B. Container A is depending on the container B. When container A is release their resources like CPU, memory, everything, and their host name and their IP, then only other resources able to use and they complete their task. It is called a tightly coupled architecture. Because of this tightly coupled architecture, if one resource hold the entire hardware capacity, the CPU, memory, everything, it is impact on the another resource, that is a container B. So this type of configuration, this type of architecture we don't have in the Kubernetes. The Kubernetes doesn't support the tightly coupled architecture. Simply it is supports the loosely coupled architecture. So now I'm going to tell you what is loosely coupled architecture. I told you that loosely coupled architecture means one resource required anything the other resources try to share and they fulfill their tasks. So when I say container X, no, pod X containing two containers, container A and container B. Container A is required some resources at that time. Container B will provide their resources to container. I mean that here we will get the shared platform for multiple resources. So it's like it is called a loosely coupled architecture. I mean that collection of components is centered around doing deployment, managing deployment, scaling applications, and sharing their resources. Uh, it is called a loosely coupled architecture, right? And finally, I want to say only one thing, that this entire information is happening in containers, only in containers. So the main thing of Kubernetes is to managing as well as to orchestrate the containers. In the containers, we will do the deployment of our applications. What are the stuff is required from OS level to from application level, we will deploy into the containers. That container we want to manage or maintain. For that, we require the tool that is a Kubernetes. So because of that, we will call as a container orchestrator. So Kubernetes is a container orchestrator, and these container orchestrators we will deploy these containers into the node pods and nodes and cluster. So this entire cluster uh, we will manage. So for that we require the tool that is so we can call Kubernetes. So Kubernetes, it is maintaining the cluster as well as, so we can call it as a container orchestrator or cluster manager. That is the beauty of the, so I guess Kubernetes. So when I say the Kubernetes, what it do means that actually we will install and configure the Kubernetes in Linux based systems. So 90% of Linux based systems use the kernel. So Kubernetes is a Linux kernel distributed environment. So and the main thing is that it is a shared node resources. I mean that underlying hardware of nodes and providing the unified interface for the applications to be both deployed and consistent shared pool of resources. Means that, so when I configure the Kubernetes in a multiple nodes which are having the Linux distribution, in that all nodes we have the OS, that is the kernel Linux basis, that is responsible for the managing the enter resource to the application from OS level to DP level, and it's a shared pool of the multiple resources. What are the resources required for that application, it will share, and it's provided a lot of things, like I mean it will do lot of things like multiple nodes, self-healing, maintenance, communication. When I say multiple nodes, means that when once we have configured the Kubernetes setup with some nodes, we want to place some containers into that nodes. At that time, some mechanism is required, that is a multiple nodes mechanism. This mechanism we will get from the Kubernetes as well as the self-healing. Suddenly any resource will goes down or any crashes either node, pod or container, we we won't replace that one. At that time we will get the some mechanism like self-healing and maintenance. After we have done and set up the configuration, we need to do monitoring, logging, health checking. At that time we looking for the another mechanism, that is a maintenance. Okay, everything is fine and setup is running fine. Setup we have done, it is good. When I say the communication between these things, node, pod, cluster, something is required. At that time, we're looking for one uh, mechanism. So Kubernetes will provide the communication mechanism. In depth, I will explain you it further. So I'm going to explain you architecture. So I told you, right? So Kubernetes is a master and node architecture. Guys, please have a look on this. This is the master and a node architecture. So Kubernetes architecture means Kubernetes containing the master and a node. So this is the architecture. So sorry guys, I told you, right, what is Kubernetes. I will explain and what it does and whatever mechanism, and I will explain you architecture. When I say the Kubernetes architecture, it is a master node setup. Means that, guys, this is the master and node, and we have different type master node setups. I mean that sorry guys. Yes. So this is guys, please have a look on this. This is a master and this is a node. This is a single master node setup. Components, I will explain you each and everything. So by using Kubernetes, we can configure single master and single node setup, as well as we can configure single master with multiple nodes. This is the another diagram, like Kubernetes single master, multiple nodes. Okay, and this is the, another diagram, like that is the single master with multiple nodes. Single master with multiple nodes. You people got a little bit confusion, right? So here I'm saying that multiple nodes means 1, 2, 3, 4 up to n. Yeah, this is the another diagram, that is multiple masters and multiple nodes. Guys, you guys are seeing minions. This is previously we called it as minions. That is a Kubernetes 2.8 version. So after 1.6 version, after coming to 1.8 version, we will call as a worker nodes. So this diagram is that multiple nodes and multiple masters and multiple nodes. So when I say the Kubernetes architecture, it is a master node setup, but we can configure that master node setup in different ways. Those are like yes, single master, single node, and single master, single node, as well as single master with multiple nodes, 2 or 3 nodes here, and single node with multiple nodes, as well as the multiple masters with multiple nodes. So in these ways we can able to configure the Kubernetes. So, and I want to show you the best example. Guys, see, this is the Google Kubernetes architecture. I will explain you. See guys, see, when we are working in IT in a 24/7 support, we will take the support of Google, right? If you got any issue, production issue, UAT, or a pre-prod, we will take the help of the Google, then we will resolve that issues. But we never think about what type of architecture it is using, right? I've gone through a lot of documents. I found this stuff. Sorry guys. So Google using the Kubernetes and their architecture like this. It is using the multiple a single master, two worker nodes. But meanwhile, it using lot of stuff. What their services, exposes, ingress, lot of things it using. So, but I don't get the chance to explain each and everything. But most of best I will give you. I mean that what the stuff if I have, I can able to give you. So this is another architecture, like this is, guys, see, this is the Kubernetes tester cluster pool. So it is in use, it is available. So this is the dev cloud, this is the production cluster. So it is already running in the pass. So we will prepare the configuration and everything. If everything is fine, then we will dump into the production setup. So before this, we need to do a lot of things, like from developers implement their code and everything. After that, they push into the git. Then after that, write the some builders files, like configuration files, some provision files, like this. Then after that, we will push into the Docker registry. So after that, we will take the necessary steps to configure the lot of intermediate tools, Ansible and everything. Then we will everything is fine. When we get the blueprint, then we will take the permission of manager. Then we will try to deploy it into the test environment, development environment. Once that, then we will what to call. Then everything is fine. Then we will implement the setup. Then we will do the sanity, smokes test, and everything. Then the same plan configuration thing. Then we will deploy it to the production. This is the beauty and the setup of the Kubernetes. Yeah, this is the once we do the deployment in pods in a containers, we want to expose into the outside. So for that, we are in this service. There is a cluster IP, node IP, load balancer, a lot of things. We will expose that services to the either ingress or egress with the HTTP or HTTPS. So this also in the further I will explain you. I'm planning over this thing also. So now, right, architecture. So architecture wise it has that. Now I'm going to discuss about the building blocks. Architecture is that, then master block. Okay. Sorry guys. So now we got to know that Kubernetes is the setup is a combination of master and a node, either a single master with multiple nodes, or a single master with single node, or multiple masters with multiple nodes. So when I say the master and nodes, so the master is that it is the major component in the Kubernetes architecture. So it's containing API servers and etc controller schedulers, as well as the node containing some components like kubelet, kubeproxy, and pods and container. So here the master component act as a primary control panel for the Kubernetes. So this is the main control plane for the Kubernetes. It is responsible for containing the major components. So those are like API server, scheduler, and controller, either cluster controller or cloud controller or DNS controller. So in these three, API server is the main component. So what are the things are there in the Kubernetes? So all components are communicating to the API server. So like users need to call users and the REST APIs, as well as the kubectl commands and sorry guys, and etc, then these schedulers, as well as these controllers, and from node level, what are that nodes, multiple nodes, as well as the pods, all are should communicating to the API server. So the API server is the main component, major component in the Kubernetes. It's behave like a heart of Kubernetes. It is this is C, guys. This is the API server component. This is the major component. It is communicating the kubectl as well as a lot of controllers like schedulers, controllers, cloud controller, kube controller, DNS cloud controller, and cloud APIs and proxies, all services, and etcd. These all are communicating to the API server, and from node level also there's a kubelet as well as the proxies as a pods, containers, everything will be communicating to the API server. So means that API server provides the fast facing REST interfaces into the control panel and database. All clients, including nodes, users, other applications interact with Kubernetes strictly through the API server. Right, guys, I told right. All components strictly communicate or interact through the API server. So this is the major component. And coming to the nodes. Nodes mean that it's like workers. So it's containing a lot of components like kubelet, some container runtime as a kube proxy, and pods and containers. So nodes are the workers of the Kubernetes cluster. So Kubernetes cluster combination containing of multiple nodes. So the nodes we can call it as workers, and they are minimal agent that manages the node itself. So these nodes containing some agent, that agent is called as a kubelet. Why we use the kubelet? The kubelet is responsible for the maintaining monitoring of the node capacity, health planning, health. So Kubernetes cluster is a combination of multiple nodes. Nodes are nothing but workers. So these workers containing the different components, and that component, the major component is agent. That is a kubelet. It is responsible for interacting interact with the API server. Oh, okay, right. So this is the architecture of the Kubernetes. So guys, then master components. Okay guys, so as per our discussion in the first session, I will explain you building blocks of Kubernetes, just introduction. In the further session, I will explain you in depth, means that master components, API server and what it does and what are their internal interactions, and etc, how, what is etc, what it stores, and how to do the backup of this etc data source data. I mean that etc stores the cluster configuration. So once it's become what to call we need to assign some space, some storage. Once the storage is huge or anything, it is met the threshold. At that time we need to take the backup, as well as normally we will save some keys and database information. We want to take the backup of that ACD data. This is most important thing, because it's simple, it's containing the key data informations. Oh, okay guys, I will explain you in the further session each and everything, like what is EPS server, etc, controllers and schedulers, as well as the kubelet and kube proxy, pod, container, etc, etc. So this is the short video for Kubernetes introduction. So thank you guys, thanks a lot everyone. Please keep supporting like this, and do subscribe, and if possible, then share my videos to the different channel. Thank you guys. Thank you and happy learning.